Hello everyone, welcome to Exemplar Physics, where we understand concepts and solve questions. We are with another video in the playlist Basics of Physics. This is continuation of the topic Force and Motion, the next part. In the last video, we have discussed about force, balanced and unbalanced force, acceleration, friction and weight. If you haven't seen that video yet, the link is in I button and in description section as well. In this video, we will discuss about effects of force in details. So let's start the video. Effects of force. Before understanding the effects of force, we must understand the states of motion. The state of motion of an object is described by its speed and the direction of motion. The state of rest is considered to be the state of zero speed. Thus, a body can exist in two states, that is, state of rest or motion. Now let's see what effects can the force cause on these states. Force can cause change in state of rest, change in speed, change in direction of motion, change in shape. Let's realize each effect clearly. Let's think about a situation in a football match. The player is ready to take the penalty kick. Everyone is holding their breath in tension. The player shoots the ball and goal. Before being hit, the ball was at rest, and so its speed was zero. The applied force makes the ball move towards the goal. That's change in the state of rest. Now let's consider a similar situation. Suppose the goalkeeper dives or jumps up to save the goal. By his action, the goalkeeper tries to apply a force on the moving ball. The force applied by him can stop or deflect the ball, saving a goal being scored. If the goalkeeper succeeds in stopping the ball, its speed decreases to zero. That's change in speed. If he couldn't but deflects the ball, that's change in direction. Now, from the world of football, let's teleport into a kitchen. See what our chef is doing there? He is kneading the dough. He applies force on the dough and that shape changes. That's the next effect. See the complete picture now. In one screen you can notice the effects of force. But wait for a moment. There's yet another effect of force. It is moment. Turning effect of force is known as moment. It is often called torque. The magnitude of moment is the product of force and perpendicular distance. See the spanner. When force is applied at one end, it leads to turning effect in bolt on the other end. The perpendicular distance is the distance of the bolt to the point of application of the force. The same principle is used to open a door. Why don't you try to open a door by applying force near the hinges? Tell me in comments what happened. Moving ahead, turning effects could be in two directions, clockwise and anti-clockwise, and we call clockwise moments and anti-clockwise moments. See the direction of motion of hands of clock. This is called clockwise, and the direction opposite to the motion is called anti-clockwise. Now let's discuss about a simple machine in which principle of moments is applied. It is called lever. A lever is a simple machine consisting of a beam or rigid rod pivoted at a fixed hinge or fulcrum. It is capable of rotating on a point on itself. See the picture. In this picture, a boy is trying to lift a heavy load using a crowbar or lever. The yellow stone you see there is the fulcrum. It is the pivot point. The load is heavy and difficult to lift. The boy puts one end of the crowbar below the load. He is applying force or effort on the other end. As a result of it, the heavy load moves up. The distance between the fulcrum and the point where effort is applied is called effort arm, and the distance between the fulcrum and the load is called load arm. An anti-clockwise torque is created due to effort. Let's call it T1. Its magnitude is the product of effort and effort arm. Remember, moment is equal to force into perpendicular distance. And also, clockwise torque is produced due to load at load arm, and its magnitude is load into load arm. Since the moments of torque must be balanced, therefore T1 is equal to T2, that is, effort into effort arm is equal to load into load arm. This equation expresses the principle of moment for a lever. The ratio of load and effort is called mechanical advantage. From the above result, we can write mechanical advantage is equal to load by effort and is equal to effort arm by load arm. One important point to be noted here is, if effort arm is larger than the load arm, then the mechanical advantage is greater than 1. Mechanical advantage greater than 1 means small effort can be used to lift a large load. Types of levers. Levers are classified by the relative positions of fulcrum, effort, and load, and they are categorized as Class 1 lever, Class 2 lever, and Class 3 lever. Let us try to understand each one of them one by one. Firstly, Class 1 lever. Here, the effort and load are on either side of the fulcrum. See the schematic diagram. In this diagram, you can see fulcrum is in between the load and the effort. Examples of Class 1 or first order lever are beam balance, here is the fulcrum. Load and effort can be placed on the either side. The next example is seesaw. Center of the lever is the fulcrum. Pair of scissors is also an example for Class 1 lever. Here is the fulcrum and the scissors. The mechanical advantage for Class 1 may be greater than or equal to or less than 1 depending on the position of the fulcrum. Now, Class 2 lever. Fulcrum and effort are on the either side of the load. See the schematic diagram. You can clearly see load is in between fulcrum and effort. Examples of class 2 lever are wheelbarrow, see, load here is the earth being moved. Here is fulcrum and here effort. Next example is nutcracker. In this, nut is the load. Here is fulcrum and effort is applied here. Bottle cap opener is also an example for class 2 lever. Here is the load. The load is the cap. Here the effort is applied and this acts as fulcrum. The important thing to note here is the mechanical advantage of second order lever is greater than 1. Let's study about class 3 lever. In class 3 lever, load and fulcrum are on either side of effort. See the schematic diagram. Effort is in between fulcrum and load. Example for this class are tongs. Here is fulcrum. Here the effort is applied and load is carried here. The another example for class 3 lever is forceps. It works almost like tongs. The next important example is human arm. Human arm is an example for third order lever. Here the fulcrum is at the elbow and we carry load in our hand. Effort is in between them. Mechanical advantage for class 3 lever is less than 1. I hope that you have understood the concept. Still, if you have any doubts, feel free to ask. Let's solve some questions to enhance our knowledge. Question number 1. Which one of the following is not example of second order lever? A. Nutcracker, B. Wheelbarrow, C. Bottle cap opener, D. Pair of scissors. In second class lever, we all know that load is in the center and hence option D, a pair of scissors, is the answer. It belongs to class 1. Question number 2. Forceps is an example for a lever of A. class 1, B. class 2, C. class 3, D. It's not a lever at all. The answer is class 3. Question number 3. Which of the following work is based on the principle of moments? A. Screwdriver, B. Spanner, C. Screwjack, D. All the above. The options A, B, C are simple machines and they work on the principle of moments and hence the answer is D. All the above. Now, question to the viewers. Please write your answer in the comment section. The question is, which of the following is not a simple machine? Option A clock. Option B, hammer. Option C, lemon squeezer. Option D, cutting plier. Please write your answer in the comment section. That's it guys, we have come to the end of the video. Thanks for watching. I hope you have enjoyed watching the video as much as I have in making it. Please share this with your friends and family members and subscribe to the channel. Bye bye.